Alright, so in this video we're going to learn how to actually use a quadratic formula to solve a quadratic equation. And there's three main steps. You have to put the equation in standard form. Standard form looks like this: ax squared plus bx plus c, and it always equals to 0. Secondly, we have to figure out what a, b, and c are, and then the last step is just plug a, b, and c into this formula right here. And that's really all there is to it. Okay, so let's take a look at each of these. I'm going to do number one with you, and then I want you to try to pause the video and do the second one, and there's a third one I'll show you as well. Alright, so here is, let me actually move it up so you can see the third one. It's right there in case you want to pause it and try it. Alright, so here we go. So number one, first thing is to put it in standard form. It's not in standard form now because it needs to equal 0, but now it's going to be in standard form. So we have 3v squared plus 6v. 6 minus 3 would be 3. And by the way, this formula says x equals, but it really doesn't matter what variable we use. In this case, we're using v instead of x. That's not important. Okay, so now we need to identify a, b, and c, and I would suggest that you put those numbers right next to this so that you have them with you when you're plugging them in. Okay, so a is equal to the number in front of the squared term, so a is 3. Okay, b is equal to the number in front of the v to the first term, so that would be 6. And then finally c is the constant. C is the number just by itself, so that equals 3. So a equals 3, b equals 6, c equals 3. Now we're going to use this formula up here. So we have x equals, I'm going to make kind of a skeleton outline of this formula, and then we'll fill in the values as we need to. Okay, to simplify, because that's really what I just did is the most important step right there. Correctly identifying a, b, and c, that's one of the few places that you can go wrong. So if you mess up there, unfortunately there's not a lot of hope of getting the problem right, but if you get that part right, there's a good chance you'll get the rest of it right too. Alright, so let's fill in the a's first. So the a's appear right here and right here. So a is 3, that's going to go here and here. Our b's appear, it's negative b, so negative 6 in this case. B squared would be 6 squared. And then finally our c is going to go right here. Okay, so we have that done, and now the last thing we really need to do is just to simplify that. So let's do that. Okay, so we have x is equal to negative 6 plus or minus 6 squared is 36, minus 4 times 3 is 12, and 12 times 3 is 36. We get 36 minus 36 over 2 times 3. 2 times 3 is 6. So we're going to get negative 6 plus or minus. This thing equals 0, and the square root of 0 just equals 0. So negative 6 plus 0 and negative 6 minus 0. The plus or minus, you could split it up. You could say negative 6 plus 0 over 6, negative 6 minus 0 over 6. Negative 6 over 6, in both cases, both of these actually turn out to be the same number, negative 1. There's only one solution to that. So if you were to graph this equation, you'd actually have a graph that looks something like this. It would only touch the axis at that single point right there, which is x equals negative 1. So there's our solution for that. Try to pause the video and do number 2 on your own. When you're ready, come back and we'll take a look at the answer. Alright, so once again, the first thing we need to do with these equations is to put them in standard form. So let's add 9 to both sides. So we'll have 7v squared plus 8v. Negative 17 plus 9 is negative 8, and that's equal to 0. So we're going to get our quadratic equation ready here to plug values in. And remember that our other important step is we need to identify a, b, and c. So let's do that now. So a is equal to 7. So the a's go in the quadratic formula go there and there. B is equal to this number right here. It's equal to 8. So it's negative b would be negative 8, and 8 squared, b squared right there. And then finally c is also equal to, or it's not equal to 8, it's equal to negative 8. You have to include that negative sign. That's important. Okay, now we can simplify this from there. So we're going to, by the way, this equals, I should say v equals, not x equals, because we're using v. So v equals negative 8 plus or minus this underneath the root. This is going to be 64. Okay, you have a negative 4 times 7, that's negative 28 times negative 8, and this whole number would be positive 224. So 64 plus 224. That's another common mistake, is people get this negative. If there's any other negatives over here, which there is in this case, you have to make sure to multiply those to give you a positive. And then the bottom is going to be 2 times 7, which is 2 times 14. Okay, let's simplify that a little bit more. So negative 8 plus or minus 64 plus 224 is 288. over 14. And now here's the thing, although 288 is not a perfect square, like on the other one we just took the square root of 0. Okay, this is not a perfect square, but it does have a perfect square listed or present under it. And here's what I would recommend to find that. I would recommend just having a list available for yourself of the perfect squares, which I will make right here. And we might have to go a little while before we locate it, but that's all right. So let's put a couple of these. We'll just list them up to certain points. 288 is not a perfect square, but that's 9 squared is 81. That's 10 squared, 11 squared, 12 squared, 13 squared is that, 14 squared is that, 15 squared, 16 squared. We don't really need to go past, I would say about 12 generally. Okay, then we started the biggest perfect square. We work backwards, see if 288 goes into it. So obviously none of these, 288 doesn't go into any of these, but actually 144 does work. 288 goes into that. It happens to be 144 times 2 is equal to 288. So this becomes negative 8 plus or minus this number equals 12. So that's the same as 12 root 2 over 14. And before we simplify this, notice that 8, 12, and 14, 2 goes into all of those. So 2 goes into that 4 times, goes into that 6 times, it goes into that 7 times. So we can write our answer as negative, sorry, it should be, we just changed that from negative 8, it should now be negative 4. We could write our answer as negative 4 plus or minus 6 times square root 2 over 7. That's perfectly fine. Some people like to split it up and do negative 4 plus 6 root 2 over 7, negative 4 minus 6 root 2 over 7. Either one of those is correct. Okay, the point is that one has two solutions. So if you were to graph this one, where would that number be? It would be, I'm not sure, but it would be something like this, and you touch it, it would touch 2 times. The reason I'm not sure is because this is obviously not a nice round number like negative 6 over 6 on the other one. We could calculate it, but the point is it has two solutions, one of them coming from the plus, one of them coming from the minus, so it's going to touch the graph 2 times. That's what it means when you actually graph it. All right, so I showed you two scenarios. We had one solution. This one we had 2 solutions. I want to show you one more, so see if you can pause it and try this one right here. This uses a concept we've used before. So let's subtract 6 to put this in standard form. So we have x squared minus 2x. 10 minus 6 is 4. And then let's get our quadratic setup ready. So negative b plus or minus b squared minus 4 times a times c, and that's all over 2 times a. In this example, a is equal to 1. Okay, so I'm going to put the a 4ac and all over 2a. And then b is equal to negative 2. So negative 2, or negative b would be negative negative 2, and then negative 2 squared. And finally, the c value is equal to 4. So that goes right here. So let's simplify that. And again, this is x equals negative negative 2 right here is positive 2 plus or minus negative 2 squared, that's equal to 4 minus, and then 4 times 1 times 4 is 16. So 4 minus 16 is negative 12. That's all over 2 times 1, or just 2. Okay, now here's the problem. Negative 12 obviously is not a real number, so we're not going to have any real solutions to this. If you were to graph this equation, it might look something like this. It actually never touches this, never goes below that, so it never touches. So we can still get an answer, it's just not going to be a real answer. Let's focus on the negative 12 for a second. Hopefully you remember from imaginary numbers, we should always start by pulling out a negative 1, because that's the same thing as I. And then negative 12 has a perfect square in it. It's 4 times 3. So this simplifies down to I times, that's equal to 2. That's equal to root 3. So we can write that as 2I root 3. So let's do that. X equals 2 plus or minus 2I times the square root of 3 all over 2. And then we notice that 2 goes into all of these numbers. It goes into that once, it goes into that once, it goes into that once. We're dividing by 1, which means we don't really need the 1 on the bottom, because when we're dividing by 1, that's the same as just having the original thing. So our final answer would be 1 plus or minus I times the square root of 3, and that's where we would stop. It doesn't have any real solutions, but it does have an imaginary solution, so that's exactly how you would leave it. So that's how you use the quadratic formula, and hopefully it made some sense to you.